In this video, we're going to look at how to create a confidence interval for a population proportion P. And we're going to piggyback off of some of our previous work because we've already made confidence intervals to estimate a population mean, mu, right? We are trying to estimate these parameters. We've estimated the population mean with the sample mean, and now we are going to see how we do that for a proportion. These are the unknown population parameters, and these in green are the sample statistics. We also have another name for these sample statistics, right? We can also call them point estimates. Because they are a single point, we know that those sample statistics are not going to equal the parameters that we're learning about. And that's in part why we create an interval around these point estimates, so that way we hopefully capture the parameter in the interval. The interval that we put around the point estimate is, you might recall, called the margin of error. Let's jump to the formula that we're going to use for the confidence interval for a population proportion. We can say CI, confidence interval, for P, the population proportion. The formula starts with P hat. That is the point estimate, or the sample proportion. We will add and subtract to that point estimate the margin of error, which is composed of a value from the Z table. We'll talk about that in a moment, and its standard error. The standard error here we saw in the previous videos. It is P times 1 minus P over N. However, that was the way we saw it in the previous video, but here we need to replace P with the sample version, and that is all in the square root. So this Z is called Z critical, and we'll talk about how to find that. And this was the standard error for proportions. Everything after the plus or minus sign is called the margin of error. If you've got space, put this in a box. We're going to use it. Well, what is this Z critical number? This is just a Z value or a Z score with a certain area in the right tail. You may remember when we did confidence intervals for a mean that alpha is called the significance level, and 1 minus alpha is called the confidence level. Confidence is usually a large percentage, such as 90 or 95 or 99% are the most common confidence levels, because we want to be fairly confident in our estimations. As such, significance is usually a small number because it's the complement, usually 0.10, 0.05, or 0.01. To illustrate this with an image, this is the Z distribution. 0 is always in the middle. Confidence refers to this middle region. Confidence. It's most of the area in the center. So if you think about that as, say, 90%, then the leftover region would be alpha. But that would need to be split into tails. So this is essentially a backwards problem. Let's do a quickie example. Like, what if we wanted 90% confidence? 0.9. Well, then alpha would be 0.10, but that would have to be chopped in half, which is 0.05. 0.05. We can figure out these tick marks. That's what this Z critical is. It's those tick marks, that Z value. If we cruise over to our Z table, we're going to try to find 0.05 in the body of the table. So that would be up in the mess, right? Because we know the probability is 0.05, and I'm looking, and I think I've gotten pretty close right there. These are actually tied with 0.05. The corresponding Z-score would be about negative 1.6, and the second decimal maybe a 0.4 or a 0.5. Maybe 1.64, 1.65. And that's negative. Because of symmetry, we get to say that on this other side of the distribution, right, this one here is negative, that one is positive. Now, every time you do one of these confidence intervals, you don't have to do this. Check it out. On our Z table, I had some hindsight, and in the bottom of page 1, check this out right here. This says critical values. Look, Z alpha over 2. And these are the critical values that apply to certain levels of confidence. And check it out too. We just did 90%. And we found 1.64 or 1.65. They actually took the average there. So this is a shortcut way, and the way that you should do it, to find these confidence interval critical values. In the next video, we will look at a particular example of how to create a confidence interval for a population proportion.